Sibois from JPL. I'd like to acknowledge my co-author, Shailen Desai. I'm going to be discussing two Earth orientation models that have been published in the past 2 years, and I'm going to show the results that we obtain when assessing the impact of replacing the conventional models with these modern models in our GPS precise orbit determination process. So this investigation is motivated by the fact that the models currently recommended by the International Earth Rotation Service for long period tidal variations in the Earth's rotation rate and length of day, as well as the semi-diurnal and diurnal tidal variations in all ERPs, so polar motion, UT1, and LOD, are over 20 years old and suffer from deficiencies that have been recognized by the community for several years. These models are also the standard adopted by most, if not all, IGS analysis centers for their operational processes. So alternatives, actually modern alternatives exist and have been shown to be more accurate than these standard models. In particular, we're going to be looking at the model for long period tidal variations in UT1 and LOD, also referred to as zonal tide model, that was published in 2014 by Ray and Aerofiva. And we're going to be discussing the ocean tide model that Shailen Desai and myself published just last year. So in the first part of my talk, I'm going to be introducing these models and describing the way they were validated by Ray and Aerofiva for the first type of model, and Shailen and myself for the second type of model. We will also be considering libration effects. So we will show that our modern ocean tide model shows improved consistency with the current recommendation from the IRS, which is the model from Matthews and Brotagnon. So to begin with, we'll look at the zonal tide model. So I want to say that, oops, it didn't come quite right. I want to say that this slide is basically a summary from the paper published in JGR in 2014 by Ray and Aerofiva. So that's the model we implemented for our test. This model has 18 additional tidal lines relative to the IRS recommended model and is shown to have also improved accuracy over that model. In addition, whereas the IRS recommended model relies on the 1981 Yoder et al. Model with subsequent adaptations and adjustments, this new model consistently includes the effects of anelastic mantle and dynamic ocean tides in all spectral lines. So the modern model is more consistent as well as more accurate. So this model was validated by Ray and Aerofiva using 20 years of space geodetic LOD measurements from the JPL Space 2008 series. So the picture that you see here was excerpted from that paper, and you can see that the two curves represent the residual LOD spectrum that was obtained from the 20 years of LOD measurement after correcting the Space 2008 series for non-tidal as well as tidal variabilities. In the case of the blue line, the tidal variability was corrected using the IRS 2010 convention model, whereas in the case of the red line, it was using Ray and Aerofiva's model. On the bottom plot, you can see that it's basically highlighting the difference between the two curves from the top plot, and you can see that the residual, there is a clear reduction in the residual signal seen using Ray and Aerofiva's model, in particular at the annual, semi-annual, fortnightly, and 9-day signal. So that's a significant improvement. I have to add, though, that in the case of GPS POD, we only use the zonal tide model for interpolation purposes. So it's during the regularization process, basically when we have our nominal daily time series from, for instance, like bulletin A or EOPC04, you use that model to remove those long period variations and interpolate to the epoch of interest before putting back the exact same model. So because we use a consistent model in each case, we do not expect to see a very noticeable change in our GPS POD results. But it's still always good to have the more accurate model implemented. So for this ocean tide model, so this model predicts the effects of the ocean tides on diurnal and semi-diurnal polar motion, UT1 and LOD. So the model we implemented was published just last year in JGR. It is based on the TPX08 hydrodynamic ocean tide model by Egbert and Eurofiva. Actually, it's noteworthy that the current conventional model by Ray et al. For UT1 and LOD and Shao et al. For polar motion components are also based on an earlier version of the TPXO model, so that our modern Earth orientation model benefits from improvements, advances in ocean modeling. And you can see that this new model has more than twice as many lines included as the IRS 2010 model. So we validated this model using 10 years of continuous GPS-based polar motion estimates at 15-minute temporal resolution. Our approach for validating the model is basically to use the background, to use those models as background model in our GPS precise orbit determination process. And then we generate a time series of continuous GPS-based polar motion observations, and we look at, we use the residual tidal signals in this series at tidal frequencies to discriminate between the deficiencies of the model from the unmodeled effects, like we don't consider atmospheric effects, for instance. So if we really look at the ocean tide frequencies, then we can say that those differences between the models are due to deficiencies in the model. So using that approach, we show that we have a closure of the budget between the predictions and the GPS-based observation at the level of 2 and 5 microseconds in prograde diurnal, prograde semi-diurnal, and retrograde semi-diurnal tidal variations in polar motion, respectively. So this is going to be more clear when I show these figures. So we have 3 figures for each of the component of polar motion. So prograde semi-diurnal is on the top corner. To the right is the prograde diurnal. We don't have the retrograde diurnal because this is by convention considered mutation. And then at the bottom we have the retrograde semi-diurnal band. So these plots are essentially differences of the residual amplitude spectra that we obtain when using the different background models. So we compare the performance of the IRS 2010 model with our new model. I have to note that for the prograde diurnal, we also include in both cases the libration model. So this is just for the diurnal prograde because polar motion is only affected by libration at those frequencies. So if you see a positive value, it basically indicates that the IRS recommended model has larger residual signals than our modern model, because the difference is recommended minus modern. So you can see that for the prograde semi-diurnal band, all major tides have larger residuals for the current conventional model. For the retrograde semi-diurnal, it's the case for N2, M2, and K2. S2 is a little ambiguous because we know that there are some atmospheric effects, so it's not clear exactly which model would be improved, would be more accurate. For the prograde diurnal, we will show the impact of libration later, but you can already see that particularly at the K1 frequency, there is a dramatic change between the two models with 18 microarc seconds difference. And Q1 and M1 are also show larger residuals for the conventional model. So the only tide for which it's the new model is basically degrading the accuracy is P1 by 5 microarc seconds. So with the new model, the residual tidal variations are at a level of 2 to 15% of predicted ocean tide effects. And from the literature, I think that for the current standard model, it's up to 20%. Yeah, you can also see that the modern model eliminates systematic signal very near O1, but if you actually look at the exact O1 tidal frequency, they are at a similar level. So we also looked at the libration model. So currently in our GPS POD processing, we exclude the libration effects because there has been in the literature some questioning about the consistency of that model with the IRS 2010 ocean tide model. And so we show here on that figure, so we show the residual tidal signal in the diurnal prograde band. And so that's the sum total of the predicted ocean tide and libration effects. So the lowest value indicates the best consistency between the libration model and the ocean tide model. So you can see that the red is for the conventional model, and the blue is for the TPXO8-based model. The pale color, the pale shade is when we don't apply the libration effects, whereas the dark shades are with libration. So you can see that in the case of the TPXO8 model, using the libration model in addition reduces the residual signals in most cases. And you can see that in contrast, when you use the libration effects model together with the conventional model for the ocean tides, the libration model tends to increase the signal, especially for O1 and K1, which is pretty spectacular because it just goes the other way for K1, for instance. So we did use that there is a better consistency of the modern model with the conventional libration model. So now I'm going to talk about the actual impact this has. So substituting the conventional models with those two modern model has on GPS POD estimates. So the methodology was that we processed 3 years, 2014 to 2016, using the JPL Analysis Center final strategy. For the baseline runs, we used what we currently use in our operational strategies, which is the 2010 IRS conventions model for both the effects of ocean tides on polar motion UT1 and LOD, and for the zonal tides in UT1 and LOD. The test runs are different because they use the TPXO8 derived model for the effects of ocean tides. They also use the IRS libration model, and we use as well the Ray and Aerofiva model for the regularization process that takes place internally. So to make sure that we had a control situation, we used the same data network in the two solutions. We used the same daily nominal Earth orientation file, which is in this case the IRS bulletin A. And in all cases, we apply, so like I said, bulletin A, two model variations with periods larger than 2 days. And we also use the conventional nutation model from Matthews and et al. So I have to note that in this, in the case of bulletin A as well as the conventional nutation model, the baseline solution is basically going to be interestingly more internally consistent because most of the centers that contribute to the IRS combination are using the IRS recommended models, and the nutation model from Matthews et al. Is also including effects from ocean tides, and it's also based on the TPXO model that is used for the conventional, the standard ocean tide model. So we do expect that this can complicate a bit the interpretation of the results that I'm going to show. So we started with looking at the simulated impact on the daily ERP values. So the ocean tide model is basically a sub-daily model, but what we really do operationally is that we estimate daily biases and rates for the Earth rotation parameters. So the way we proceeded was to compute time series of the model. So again, TPXO8 and libration versus IRS 2010 model without libration at 5-minute interval, which is our data rate, and over 30-hour arcs, because that's our standard arc lengths at JPL. Then we computed the average ERP values over each arc and computed the periodograms of the mean values, and then we plot the difference in the periodogram. So this is what you are seeing here. So you can see that the impact is very small at the 1 micro arc seconds level for polar motion, and at the less than 0.5 microseconds for LOD. And so basically the peaks that you see are mostly related to the sampling and the impact of the difference in the model with this sampling technique. So it's basically annual and then some kind of harmonics and 14 days. So now we look at the actual impact on the GPS solutions. So you can see that right away the actual impact on the polar motion is larger than the modeled impact by about an order of magnitude. This is because, of course, when you do a GPS POD, then in a network solution, you introduce a lot of correlation, and so it's not as simple as just the simulated impact. So for the same reason, the periods at which those differences manifest is not identical to the simulated effect. So we have some draconic signal coming in there. So you can see that those periods are a bit shifted. So basically, you can see that for polar motion, we kind of remove some signal around the annual, but then we kind of add and remove around the 2-week signal. So those results are pretty matter of fact because it's just hard to interpret them, and that's just what using different models give you. So those are the polar motion rate, and you can see that it's at the pico arc second level. So now we looked at what we usually look at for POD. So the post-switch residuals, you can see a very, very slight improvement. So it's, again, it's over 3 years. And you can see in the RMS values of the PC and LC residuals that it goes in the right direction, meaning that the modern models are reducing those residuals. We looked at our orbit and clock precision through internal overlaps, and again, if you look, it's very small, but it's in the right direction again, at least for the RMS values. And then if you just difference the day-to-day solutions, like the baseline solution with our test solution, you can see that the difference between the two is basically less than 2 millimeters in orbits and clocks. So it's a minimal effect. We also look at the ambiguity resolution because this is improvement in bias fixing is actually implying better measurement modeling. So that was an important metric. So again, you can see a very slight, when you look at the cell, very slight overall tightening of the histograms closer to the integers for solutions corresponding to the modern models. So to conclude, the modern models are available for impact of ocean tides and tidal deformations on Earth rotation parameters. In particular, we show a better consistency of the modern ocean tide model with the conventional libration model, which we had to exclude from our operational processing due to some inconsistencies before. As expected, due to the fact that we only use the zonal tide model for internal regularization, we don't see any impact of switching the modern zonal tides model for instead of the conventional one. And so the impact on the GPS POD is a small but still detectable improvement relative to the use of the IRS recommended models. And that concludes my presentation.